Hi, in this video, we are going to discuss the overview of MRI. So before going to start studying MRI, we have to take that we don't need to think that MRI is very hard to understand. It's very difficult to learn. Nothing like that. So like it's an overhype. Just we need to understand the basic. So we'll start with a fresh mind that we can learn MRI. So what is actually MRI? M in the MRI stands for magnet, R in the MRI stands for resonance, and I in the MRI stands for imaging. So M is magnet, R is resonance, I is imaging. Then we need to define one by one. What is actually magnet? What is actually magnet? So just we'll give a simple definition for magnet. What is magnet? Magnet is something that create magnetic field. Magnet is something that create object that creates magnetic field. Magnet is object that create magnetic field. Clear? Then how these magnetic fields are created? According to Maxwell theory states that when a charged particle moves, accelerate, it creates alternating electric and magnetic field. When a charged particle, it can be a proton, it can be an electron. So whenever a charged particle moves, it creates magnetic and electric field. So here we'll consider the magnetic field. So when a charged particle moves, it creates magnetic field. So whenever an object creates magnetic field, we can call that object as magnet. Is that clear? So magnet is something that creates magnetic field. And how magnetic fields are created? By the movement of charged particle. Keep that point aside. We need that point later. So magnet is something that creates magnetic field. And how magnetic fields are created? By the movement of charged particle. Now resonance. In the schools, we have learned a complex definition of resonance. I don't want to read the definition. Just keep in mind that resonance happens when an object gets a matching frequency. So keep in mind, resonance happens when frequencies got matched. We can relate that into romance. When we can say two people are in romance, when their frequency get matched, right? Like that, resonance happens when frequencies got matched. An object, if an object gets a matching frequency of the same object, it get resonate. It resonates. Then what is the result of resonance? Result of resonance is vibration with greater amplitude. It vibrates with greater amplitude. Our radio systems work with the principle of resonance. Our the car lock, central lock of the cars work with the principle of resonance. The lock will be having a frequency. So if you are sending the same frequency from the key, it resonates and vibrates with a greater amplitude, it lock and unlocks. Clear? So resonance, keep that point. Resonance is nothing but matching of frequency. If the frequency got matched, it vibrates with the greater amplitude or it excites. So resonance is matching of frequency. Resonance happens when frequencies got matched, and the result of resonance is excitation or vibration with a greater amplitude. Clear? Yes. Now by using this magnetic property, resonance principle, we are going to image what? We are going to image human body, right? By using MRI, we are imaging human body. So we need to know what the composition of human body. Human body is made up of different organ system. We have nervous system, we have cardiovascular system, we have digestive system, we have respiratory system, we have urinary system, we have reproductive system. So the human body is made up of different organ systems. So by using magnetic property and resonance principle, we'll be imaging any of these organ systems. Then how these organ systems are formed? Organ systems are formed by different organs. For example, digestive system. In the digestive system, it's composed of mouth, oral cavity, esophagus, stomach, duodenum, intestines. So different organs are combined to form an organ system. So by using magnetic property and resonance principle, we are going to image any of this organ. All right. So how these organs are formed? Organs are formed by the combination of different tissues. Different tissues combine to form an organ. Different tissues like epithelial tissue, columnar tissue, connective tissue. So different tissues combine to form organs. Then how tissues are formed? By the combination of cells. So by using magnetic property and resonance principle, we are going to image cells. Cells are composed of, inside the cell we have nucleus, we have ribosome, we have mitochondria. So by using magnetic property and resonance principle, we be imaging any of these cells. Then how cells are made up of? Ultimately, all matter is made up of atoms. So we can say the human body is made up of atoms, and we are, by using magnetic property and resonance principle, we are going to image atom. We are going to focus on atom. Inside the human body, 75% is water. 75% is water. Water means H2O. We have 2 hydrogen atom, 1 oxygen atom. So since because of the abundance of this hydrogen atom inside the body, we are making use of the movement of hydrogen atom for imaging for imaging human body. So in MRI, we are making use of the hydrogen nucleus or hydrogen atom for imaging. Why hydrogen? Because of its abundancy. Most of the all part of the human body have a presence of hydrogen atom. So since we are, by using magnetic property and resonance principle, we are going to target the hydrogen atom. We need to know the structure of atom. Inside the atom, we have a nucleus. Most of the mass of the atom is concentrated inside the nucleus. Inside the nucleus, we have positively charged proton and chargeless neutron. So we need to know the structure of atom. Inside the atom, we have nucleus. Most of the mass of the atom is concentrated in this nucleus. Inside the nucleus, we have nucleons. Nucleons are protons and neutrons. Proton having positive charge and neutron doesn't have any charge. Clear? And we have electrons. We have electron spinning around the nucleus. Spinning around the nucleus, and electrons having negative charge. So inside the atom, we have nucleus. Inside the nucleus, we have proton having positive charge, neutron doesn't have any charge. And around the nucleus, we have electron doesn't have any charge. Is that clear? Right, that's a composition of atom. Now we need to know the movements present inside the atom. Basically, we have 3 types of movement inside the atom. What are those? Electrons are spinning on its own axis. First type of movement, electrons are spinning on their own axis. Second type of movement, at the same time, they are revolving around the nucleus, orbiting around the nucleus. The same way how they have a planetary motion. The planets, how they revolve around the sun, they'll be spinning on their own axis. At the same time, they'll be revolving around the sun, right? Same way, electrons have the spin on their own axis. At the same time, they'll be spinning around the nucleus. So electrons have 2 movements. They're spinning on their own axis. At the same time, they are orbiting around the nucleus. And we have one more movement, that is nucleus, or the proton inside the nucleus have a movement. Clear? So nucleus, we have 3 types of movement. Electron spinning on its own axis, electron spinning around the nucleus, and the nucleus or the proton inside the nucleus, they have a movement. So we have a movement in the nucleus. The proton inside the nucleus have a spin. What is the charge of proton? Proton having positive charge, and they have a movement. What happens when a charged proton moves? According to Maxwell theory, already we have discussed, when a charged particle moves, it creates magnetic field. So inside the human body, the atoms, inside the nucleus, we have proton having positive charge, and they have a movement. Since a proton having positive charge and they have a movement, it creates magnetic field. Since it creates magnetic field, We can call this proton as tiny magnets, right? Am I wrong? No. Since proton inside the nucleus, they have a charge, positive charge, and they have a movement. If a charged particle moves, it creates magnetic field. If it creates magnetic field, we can call it as magnet. So we can say the human body is made up of tiny magnets. So this effect, magnetic effect, is used in MRI. So we are making use of this movement of hydrogen proton or hydrogen nucleus for MRI imaging. Not just a hydrogen atom, we can use any element in MRI if they have a net spin. Now in a clinical scenario, we are making use of hydrogen protons. But we can make use of any element as MRI nucleus if they have a net movement. So we cannot use a new element they have even number of proton as MRI nucleus. If we cannot use an element as MRI active nucleus if they have even number of proton. Why not even number of proton? If they have even number of proton, even atomic number. For example, give me an example of element having even atomic number. Hydrogen atomic number 1. Next element helium atomic number 2. So they have 2 protons. So inside the helium nucleus we have 2 protons. One proton will spin in one direction and another proton will spin in opposite direction. So that it will cancel out each other and will not be having net spin. There will not be net movement. If it doesn't have a net movement, then no magnetic effect. So what see, we have a rope in our hand. So in the end of the rope, 2 persons are pulling the rope in the opposite direction with the same force. Then to what direction the rope will move? Rope will not move, right? So if the element having even atomic number, half of the proton will spin in one direction, half of the proton will spin in opposite direction. So the spin will get cancelled out each other and will not be having net spin. So the elements with having even atomic number cannot be used as MRI active nuclei. Clear? So why we are using hydrogen as MRI active nuclei? The primary reason is abundancy, and the second reason, it have a net angular moment, net spin. So principle of MRI is based on the movement of this nucleus or proton inside the nucleus. Clear? So we have examples of hydrogen MRI active nuclei. To consider an element for MRI active nuclei, it should have a net angular momentum. To get a net angular momentum, it should have net spin or it should possess electrical charge. Clear? Hydrogen 1, carbon 13, nitrogen 15, oxygen 17, fluorine 19, sodium 23 can be used as MRI active nuclei. But in clinical scenario, we are using hydrogen. Why only hydrogen? Because of its abundancy. Clear? So now we are going to discuss the orientation of this hydrogen protons in the presence and absence of external magnetic field. Now me or you are not, I hope you are not inside the MRI room. So in the absence of external magnetic field, the hydrogen protons inside the human body will not be having any orientation, will not be having any direction. They will be having a random orientation. So in the absence of external magnetic field, if the patient is in the waiting area outside the MRI room, the protons inside the body will not be having any particular direction, any particular orientation. They will be having random orientation. See here, the protons here, they have random orientation without any particular direction. So if they doesn't have any particular direction, they will not create any net magnetic effect. I used to compare this orientation of proton inside the human body in the absence of external magnetic field to the orientation of students in a classroom in the absence of a teacher. In the absence of a teacher, how the students will be oriented in a classroom? They'll be running here and there. They'll be standing. Some students will be crazy. Students will be standing over the table. Some will be talking by turning backside. They will not be having any particular direction orientation. They will be having a random orientation. Similarly, the same way, the proton inside the human body will be having a random orientation in the absence of external magnetic field. Clear? So it will not create any magnetic effect. Now, if we keep this human body, the proton, under the influence of external magnetic field, means we are keeping the patient inside the MRI room under the influence of external magnetic field, then the proton will orientate according to the strength of the magnetic field. Most of the proton will align parallel spin up direction to the external magnetic field. Few proton will align anti-parallel direction, spin down to the external magnetic field. How? Same way like a classroom. If the teacher comes into the classroom, what happens? If the students are under the influence of a teacher in a classroom, they will align parallel towards the direction of teacher. The students walking here and there will come down, they will come and sit towards the direction of teacher. Those who are standing or sitting over the table will sit towards the direction of teacher. But a few students, some crazy students, they will not mind whether the teacher comes or not. They will continue their business. They will be turning back and they will be talking, they will be gossiping. So it will be a less population, right? But so like that, under the influence of external magnetic field, most of the proton will align, spin up parallel to the external magnetic field. A few of the proton will align anti-parallel to the external magnetic field. Since most of the proton are in parallel direction, the net magnetic vector will be in the longitudinal direction or z-axis. Most of the spin are in parallel or spin up than anti-parallel or spin down. So the net magnetic vector NMV will be aligned parallel or longitudinal in z-axis. So the net magnetic vector will be in longitudinal magnetization. Why? See, because most of the proton are in parallel to the external magnetic field. Is that clear? Yes. So if the proton inside the human body had a random alignment in the absence of external magnetic field, when we kept inside the MRI machine, they aligned parallel and anti-parallel. Even before keeping under the influence of external magnetic field, they had a spin, they had a random movement. When we are keeping this proton under the influence of external magnetic field, they will align parallel and anti-parallel. At the same time, the spin of the proton will be increased. That spin of the proton, increases spin of the proton under the influence of external magnetic field is called precession or precessional frequency. What it is? Already, even in the absence of external magnetic field, the proton inside the human body had a spin. If we are keeping this proton under the influence of external magnetic field, they will align parallel and anti-parallel. And they will be getting an extra spin. That extra spin gained by the proton under the influence of external magnetic field is called precession or precessional frequency or Lamar frequency. That is, we can write it as omega. The Lamar frequency omega is equal to gamma gyromagnetic ratio into B naught, magnetic field strength. So what is precessional frequency or Lamar frequency or precession? The spin of the proton or the frequency of the proton under the influence of external magnetic field. The extra spin gained by the proton under the influence of external magnetic field is called precession or precessional frequency or Lamar frequency. Is that clear? So it's very important. So this precessional frequency depends upon the magnetic field strength. The omega can be read as omega is equal to gamma B naught. Omega is the precessional frequency spin of the proton under the influence of external magnetic field. Gamma is a constant gyromagnetic ratio, and we have B naught is the magnetic field strength. So we have to keep the point in mind that the omega precessional frequency that is proportional to B naught. What does that mean? All proton, different hydrogen proton, nitrogen proton, oxygen, they have identical precessional frequency, and it will be changing depends upon the magnetic field strength. What does that mean? The same hydrogen proton will not be having same precessional frequency under the influence of 1.5 Tesla machine and 3 Tesla machine. Under the 1.5 Tesla machine, the proton will be having a frequency that corresponds to 1.5 Tesla. Under 3 Tesla, will be having a frequency that corresponds to 3 Tesla. So greater the frequency, greater the magnetic field strength, greater the frequency, precisional frequency. Lower the magnetic field strength, lower the precisional frequency. So the precisional frequency of the proton, it is influenced by magnetic field strength. Clear? Yes. So if we change this proportionality sign, we can write it as omega equal to, then a constant will come, that is our gyromagnetic ratio constant. So from this equation, we can write the equation for gamma, gyromagnetic ratio is omega divided by P naught, right? Gyromagnetic ratio gyromagnetic ratio gamma is equal to omega, precisional frequency omega by B naught. So if we are assuming that we are using 1 Tesla machine, if we are keeping the magnetic field strength as 1 Tesla, then we can write gamma is equal to omega by 1. Omega by 1 is omega. So from this we can give a definition to gamma, gyromagnetic ratio. Gyromagnetic ratio is the precisional frequency of the proton when magnetic field strength is 1 Tesla. So what is gyromagnetic ratio? It's a constant. And it is the precisional frequency of the proton when magnetic field strength is 1 Tesla. Clear? So what is gyromagnetic ratio? It's a constant and it's the precisional frequency of the proton when magnetic field strength is 1 Tesla. Is that clear? So now the proton, when we have kept under the influence of external magnetic field, they align parallel and anti-parallel. Since most of the proton are in parallel direction, we can call the net magnetic vector is in longitudinal magnetization, and they have a spin. The spin is called precisional frequency or Lamar frequency. Here we have the precisional frequency or gyromagnetic ratio of different elements at 1.5 Tesla. Yes. Now, the protons, the human body is under the influence of magnetic field. Now we need to create the impact of resonance. So when we kept the patient under the influence of external magnetic field, they align parallel and anti-parallel. Since most of the proton are in parallel direction, we can call the net magnetic vector is in longitudinal magnetization. And these protons are they have a frequency of omega equal to gamma B naught. I hope it is clear till here, right? Now we need to create resonance. In the beginning we have discussed how we can create resonance. We can create resonance by matching of frequencies. Now what is the frequency of the proton here? That is omega equal to gamma B naught precisional frequency. So if we are giving a frequency that is matching the precisional frequency of the hydrogen proton, then we can resonate them. For that we are sending RF pulses. Why RF pulses? Pulses means like if we are switching on, switching off, we'll be switching on, switch off, switching off. That's all. That will create pulse. So we are sending RF pulse, that is match radio frequency, radio waves that have a matching frequency to the precisional frequency of the hydrogen proton to create resonance. Why we need to create resonance? See, if you're going back to the classroom example, the teacher continue to take the class after 20 minutes or 30 minutes, even the students, they are directed towards the teacher, they'll be get bored, they will be having a tendency to turn back and talk, but they doesn't have the energy to turn back. Why? They are under the influence of teacher. So if we imagine now the frequency of the student is they have to turn back, that is their frequency. Then if they doesn't have the energy to turn back, if the teacher says now the class is over, you can turn back and talk, now frequencies got matched, they got the energy to turn back, right? Like that, the protons in the parallel direction or longitudinal magnetization will be having a tendency to come down to anti-parallel direction or transverse magnetization, but they doesn't have the energy. By giving matching frequency or by resonance, they will gain that energy to flip into transverse magnetization. So when resonance happens, when they got a matching frequency, so when the Protons got a matching frequency, that is matching to positional frequency of the proton. Omega equal to gamma may not by radio frequency pulse. They will flip into transverse magnetization. Now they got energy to come down or flip into transverse magnetization. After some time, if we are switching off the RF pulse, what happens? They will lose the gained energy. They will go back to the longitudinal magnetization. If they are while going back, they will release an energy in the form of radio waves. These radio waves, these signals are collected by radio frequency coils placed on the patient body, and that signal is used to produce MRI image. I repeat, when we are keeping the patient inside the MRI machine, they will align parallel and anti-parallel. Most of the proton are in parallel direction. So net magnetic vector is in longitudinal magnetization. And the influence of external magnetic field create an extra spin on the proton, that is positional frequency. To create resonance, we will be sending radio frequency pulse. And by sending a radio frequency pulse, it resonates and it excites the transverse magnetization. By getting RF pulse, it excites. And by switching off the RF pulse, it relaxes. While relaxing, they have to lose some energy. That energy will be loose. The gained energy will be loose in the form of radio wave. The proton will emit radio waves. These radio waves can be collected by using radio frequency coils. Even we are sending the radio frequency pulse by radio frequency coils. The same, the emitted frequency also will be collected by RF coils placed on the patient body. These signals are used to produce MRI images. Is that clear? Resonance have a complex definition. I don't want to explain it, but just keep in mind that what is resonance? Resonance happens when the frequency will get matched, and the result of resonance is excitation. Clear? Yes, that's the basic principle of MRI.